let me share my screen. Okay, so I will just go through this Kotlin documentation related with inheritance to make you understand. But it is, as I said, it's in all languages actually have some kind of, all object-oriented languages have this thing. So what is object-oriented to start with is that, so we have some objects, we have some classes that can create a hierarchy between each other, which this hierarchy can have some agreements in between classes, or that they can just use their properties, which can be a part. For example, one class could be a parent of another, or one class can use an interface, which we call interface, to define between the communication with other classes. For example, this is in object-oriented world. This is basically it. So let's go through this document, and I will try to make things clear for you. So what is inheritance? As I said, it's a parental relationship between classes. So once you define a class, here is a class example, for example, it can have a parents, which here, as you can understand, it's defined as base. This base class will be used for a derived class. And it is done by using this two dot symbol, as you saw here. In the examples we created, like there was an activity class, as you might remember, and it was deriving from an Android, another Android activity class, the same way. So this means that the class, the child class, will use the same properties or the methods as or some of it at least from the base class itself. So if we go through it, you can see, for example, here another example is my view is taking using view class, and it has the same constructor properties. So okay, we will make it more physical so that you will understand. It's another example here called shape. So circle is a shape too, or a rectangle is a shape, square is a shape. So, but they all have different properties, which is making this more meaningful, I believe. So, but there are also same things. So they all have a shape. All circles, rectangles can be drawn with some specific properties. They have some edges, and they have, or maybe they don't have edges, maybe they have infinite edges like in a circle. So here our shape is our base class in this example, and it is defined as open keyword, as you can see here. In Kotlin, we use this word to make it usable by other child classes. If you will not add this, then this means people cannot use this class as a base class to others, which is some kind of let's make it say it as a security thing. It's not related with security. It's more about the contracts between classes. So this is a word that defines the contract that it could be used as a base class. This class has a method called draw. So if you will check, shape is an abstract meaning. It's like, because shape means all of those things like circles, rectangles, but on its own it doesn't mean anything, you know. So most probably in this case, draw will not have an implementation. It will just be a contract method or field, because we just don't know what we are going to fill. So here in the circle, as you can see, we have this draw method, which is overriding from the shapes draw method. So, but for circle, we exactly know how a circle is supposed to be. So we are going to code a drawing method of what it would be inside circle. Yeah, it would be also might be related with field, but as you see here, we draw method is also open. So this method could be overridable by a circle. The same way there's rectangle, as you can see, but the idea is same. It could be also the properties that we are defining. These could be overridable by the child classes unless they are not defined as val, so that they can be changed. So here in this example, rectangle has a constructor parameter. This is a class which has 4 vertexes. So and it's coming from shape, as you can see. Let's go through the examples. What else? Another thing. So when we are creating these objects, like creating a rectangle, for example, if there are things defined in the shape class, because the shape is a base class, as we say, it's that it will have it will also first call the methods defined in the shape class, then it will call the rectangle class. So here in this example, shape is a class, as you can see. So it can have some implementation of things, but there is another concept in which we call interface, and here it is an interface. Interfaces doesn't have any implementation. So as I said, this is more of a contract instead of a implementation. So shape, the classes who are deriving from shape needs to have a vertex. So we are just defining this contract in our classes so that the users of our classes will also need to have this. So what does this all mean? I mean, this interfaces or the parentship between classes gives us an opportunity that we can have different objects having different properties and implementing all these things on their own way. This protects your code. This gives a purpose to your code in a way that it will be used as the way you want. First of all, it prevents you to write additional code. So if you will not have this, for example, if you will not define the rectangle as a type of shape, you need to have this vertex or draw or any other method you would define separately, and they need to be written again and again for all these classes. So we are unifying our code in one way. The other advantage is the reusage, and because of these types, whenever, for example, we will add these objects, which are all actually a shape, into, let's say, an array, or we can take this data from a database. Instead of writing if conditions like we talked about 2 lessons ago, like for example, if the rectangle has, if the type of this shape is a rectangle, then draw it like this, or if it's circle, draw it like this. Instead of doing that, we are just we are calling these methods, and methods of these classes already knows what they're going to happen, how they are going to work. So if we will go, for example, here in the example, rectangle is also defined as an open class because we defined another object called field rectangle. It's pretty much same with the rectangle, but it has a filling color as an additional property. Here an inner class defined inside, but I will not get into this for now. Yeah. So before Kotlin, actually, we weren't able to define. The best way is to have one parent for all these classes. But in this example, there could be one parent. Let's say a rectangle is the parent of square. But polygon here, as you can see, is defined as an interface, which doesn't have a code inside, but it gives us a different way of doing things. So we need to define. So as you can see, these are same methods. If we will define both rectangle and the polygon as try to make it as a parent of this square class, then we need to choose which one we're gonna use. But this is just a detail. So let's go fast and go to the interface part here to give you more example. One key difference between parent classes and interfaces, as I said before, interfaces are just contracts, so they don't have any implementation. All their properties or methods are called abstract. So abstract, as you can understand from the meaning of the word, it just defines what the classes that are using this interface supposed to have or supposed to implement. So if there is a property that is defined in the interface, then the child needs to have this property field. So this property is defined here in this child as 29, as you can see. Or other way is you can also define this property as abstract, and the subchild of this child supposed to implement this property. There are things that about inheritance itself, like, for example, this also gives you the opportunity to, so for example, the base class, let's say we were talking about shapes. A shape can have, can be a base class, rectangle could be its child, field rectangle could be the subchild. All these methods, all these classes can have their own implementation of the specific methods. For example, drawing, we called, or filling a place. The base class will be called first, and the second one would be the child class in this case. But you can also make it by using, while I was showing the override word here, we can also override and change it, or we can actually use the base implementation, and upon that we can have another implementation in this class. So for example, we can draw, like in rectangle can actually have the draw methods here. It's not in the example, that is drawing for word text rectangle, but the field rectangle can also called here again, I guess it was somewhere here. Yeah, field rectangle can call this super draw method, which will call the rectangle's draw method. And upon that, it can also call field color method if we would have this thing. So that will also reduce the code in our implementation and make things more clear. So that is the basic mentality that you need to understand. It is more about understanding why we are having these contracts, why there is parental relationships between classes like there is. Of course, I know that you have questions. This is a very broad subject that hundreds of books are written related with it. And in time, you will understand it way better. But I would like to have your questions if you have some for now. Okay, I guess we don't have any questions. So from this lesson, what you need to understand is the basic usage of this parentship, the mentality behind it, as I said. So there are parent classes, which we can use it with this 2 dot as to make a rectangle the parent of square, for example. There are interfaces that doesn't have any implementation. As I said, these are just defining contracts. We will get into the usage of these interfaces later in the academy. We have this override method to override the methods that are coming from the parent, and we have super calls here to also call the parent's draw method here, as you can see. So this was all from me.